Our Asjad presenter today is the Vienna School of Economics. He's going to be presenting today on advanced visualizations with Stata #2, complex data structures. So please welcome Asjad.
Thank you, David. We have quite a bit of a ground to cover. So as you see from this topic that it's advanced data visualizations with Stata Part 2. So I did it as a sort of follow-up to Part 1, which was done in the Stata UK conference, where it was more of an introduction to, I don't know, a bunch of visualizations, and it was like, this is all one can do. So here, what I want to do is focus on two types, which are visualizations that are in polar coordinates and visualizations that do with spatial data. And what I want to cover is what has been done and some stuff that nobody has seen before that I want to preview now, basically in this conference, and then get your feedback and then have some comments on, you know, stuff or features we would like to have in Stata to make this even better. So just a bit of background, if you have no idea who I am. So I'm currently based in Vienna, Austria. So I've been in academia and research for some 20 years. My first thing with Stata was in 2003. So I had moved from TSP and MATLAB and SPSS. And so, you know, at that point, it was super intuitive. And, you know, since then, it's been one project after the other, data management, workflow analysis. I go through more do files than I would like to go through. Now even more so, I just get emails with do files and I have to check for code. And so how did I get in all of this database stuff? So, you know, work from home, middle of first half of 2020, you know, these visualizations were exploding and we were all stuck at home, and I was always pushing myself to do a bit more with Stata. And so I would say, okay, let's see how far we can go with this. And then the response was just overwhelmingly positive. And I started writing about this, and then I also got positive response about that. And so, you know, I'm just going, I keep on going with this flow. So why do we need more Stata visualizations? First of all, there are few official release for graphs. Yeah, so a lot of development is happening on the analysis side. So the last major development was adding transparency or stuff like that to graphs. But having said that, Stata has an extremely flexible structure. You know, it's a language, so it can do all sorts of mathematical operations. A lot of stuff has been developed in the past. So if you look at Benyan's whole suite of packages, you have Mario Pisati's SPMap, you have Picard's bunch of packages that deal with spatial data. And so I said, let's take this, put them together and see what we can come up with. And then once we come up with what we can do with all of these, let's see if we can take them further and develop new stuff. And so, like I said, these are the overview, which is polar plots, map, and, you know, other stuff that I will briefly showcase. So the whole presentation is done in this neon scheme, which is available as part of this scheme pack. So you can also download and install it if you're doing these dark presentations. And so starting on with the presentation on polar coordinates. So polar coordinates are basically a transformation of Cartesian coordinates. You have an XY pair and you can transform it into a polar coordinate. And so these are the basic formulas. We're not going to discuss any formulas, but let's say this is basically it to start you off with. And so one of the first things that I did with polar coordinates was to transform, you know, straight lines into circles or spirals. And so this was the very first data visualization that I came up with that had to do with spirals. And so the idea was to start plotting here weekly deaths, because, you know, you have calendar months that do a full cycle. And so you can also notice that there is some sort of continuity in how the data is evolving. So, you know, otherwise what you would have had is that you would have a line starting from week 1, ending up to week 52. You would have gone back week 1 to 52, but here you can see sort of seasonality and all of this stuff. And so these figures are very old. Basically, I just updated the code a couple of weeks ago. So the idea was to start looking at seasonality and start thinking in terms of, cycles. And so once we get into this mode, then we can start coming up with other types of visualizations that utilize this whole circular framework. So this is another example, which are spider plots. So even though there is a command for spider plots in Stata, it's fairly old. So I said, okay, I'll just reprogram this again and come up with a structure which is way more flexible. So here I've just done a random presentation of looking at COVID-19 policies. So I've thrown in Australia also in there because, I was doing this today. So here what we can see is that we can use these sort of structures to start comparing groups also. Again, spider plots are not new. People have seen them. But for some visualizations, they can really help with comparing different groups. And so other things can be done. So this was exercise where I wanted to do was this text wrapping. So the idea was to start looking at more complex polar coordinates. So this is again, the design looks nice, but the idea was to start exploring parametric plots in polar coordinates and see how far we can take them in Stata, for example. And so the reason all of this done was that I was again online, and we were online. There was this Du Bois challenge, and I said, okay, I will make these graphs with Stata, and I will, figure out how to do all of this. And so let's say these were the two images that I came up with. This is early 2021. And this had to do with, again, quite a bit of reprogramming the course structure to come up with these images. For example, here you see this pie-shaped figure, which is not a full pie chart. So, you cannot do partial pie charts in Stata, and you cannot do partial pie charts with added options like labels and stuff. So again, the whole idea was to reprogram the whole structure and just create them from scratch. And again, similarly here, what we see is the spirals with spiral text wrapping. So yeah, so this is where it all started off from, where I was like, okay, let's see how much we can do and how much we can come close to, doing data visualizations as compared to other softwares like R or Python, which are basically the main languages people work with for this kind of stuff. Yeah, so again, here the response was also extremely positive with this whole challenge. So it was also used in a bunch of other places. And so this image came up, which was by this New York Times article on these spider plots. So it was hugely controversial whether it's good data visualization or bad data visualization. But my aim was to recreate this in Stata. So I managed to do it. So I will write up briefly on how to do it, but this is my own rendition of that graph where I basically say, okay, each spiral is a year starting from 2020, 21, going up to 22, and we have cases and deaths as spikes coming out from this chart. Again, this is a visualization I would basically not use anywhere. So this was more of a programming challenge that I wanted to see that can we even do this. So yes, we can. So this is a new visualization that nobody has seen before, which was to start looking at these sunburst plots. So here the idea is that you have categories on the inner rim, then you have categories on the outer rim, and you can even have more and more. And then again, the trick to do this was again to generate these arcs manually. So a lot of programming had to go into calculating the percentage shares of this, figuring out how to do the labels correctly, because you can see on the right half, the labels are facing one direction, on the left half, the labels are facing another direction. And this had to align with how Stata deals with circles. So it's basically deals with the top half and the bottom half. And so again, quite a bit of transformations in terms of how one deals with coordinates. Again, how the colors are pushed onto the graph. So you have a main color, and then on the top layer, you have a muted version of that color that's now graduated from that color all the way to gray. So it gives you sort of a, gradient descent sort of visualizations. And again, other things like label rotations, aligning them with the center point, creating the center circle. So this was done last week. So I could not fine tune it more than this. But the idea was that, we can do sunburst plots in Stata, which is a fairly complex data visualization. And my original aim was to do it with many different layers, and I might still put something out there. So like I said, since Stata can handle these kind of stuff, and the way Stata works with polar coordinates or circles, that works with a top circle and a bottom circle. An easier version of this is to split it into a semicircle, which we come up with sort of like a half sunburst plot, which is structurally much more easier to construct than a full circle, and is also visually easier to read, because given that our screens are rectangles and circles take up quite a bit of space. And so this was next version that I created, where we just do a half circle, and then basically it's easier to compare these things with each other, and it fits neatly on the screen. So again, this is just data pulled on this date. So it tells us that there has been a total of more than 5.7 million deaths till February 3rd. So if we do it by normalize it by population, you can see how the distributions change. For example, Oceania is extremely small in absolute numbers, but in per capita terms, it still stands out quite a bit. Similarly, Europe is relatively evenly spaced within these categories, the large continents, but in per capita terms, it's quite a huge share of deaths. But I'm not going to go into the numbers. The idea is that programming this visualization was a lot of fun, and because I wanted to do this for this conference, I said, okay, I will sit down and work through the nights and do my code and get this out of my way. And so the idea with these polar coordinates is that a lot more can be done, for example. So a visualization that I discussed quite a bit in my last data visualization presentation was these art plots, where you have categories, where you have stuff moving from one category to another category. And so again, it has to do with constructing these semicircles, finding how much their widths are. These type of visualizations are usually fun to look at. They work in very few circumstances, but again, here the option is to do this as a programming challenge rather than really push myself to come up with some application to do this. Another type of graph that has been hugely popular is the Sinkey. So it's one of those graphs which people really send in a lot of queries in terms of what they want to do with this, or how to program this, and errors and bugs. So this is something that I'm super interested in converting into some package that people can use rather than go through this super complex code structure, because it requires us to align layers, come up with how to generate these arcs, connect them, assign the colors. So it gets fairly complex, because you're just have these massive nested loops that go through all these different combinations and then come up with this final figure. So yeah, so starting from all of this, like this is all polar coordinates leading into, okay, let's see if we can do these more complex data visualizations in a more horizontal form. So this Sinkey was one of them. But besides being, so Sinkeys again are a type of visualization that work in certain instances. One cannot use them always, because the more data you have, the more complex it becomes and harder it is to interpret. And so this is another visualization that has been fairly popular, which are these stream plots. So here it's fairly easy. This is just a line graph, basically. So basically all you do is you're recentering on a mean value of each day. So you take the average of each day, recenter the graphs, and then connect the lines, and then do the area fill. So what we're doing here is that we're connecting these lines, combining it with the color palettes package and pushing them in. I think when I did this, this was inspired by the Financial Times visualization that was doing the stream graphs. I think they still do it. The idea here was to sort of show waves, and then what we can see here very easily in this graph is that, we are still somewhere in the middle of, global deaths. So there's still more than 8,000 deaths happening, and then we can see by split where it's happening and their shares, for example. This was another visualization that really gets a lot of attention are these joy plots or rich line plots. Again, they make it extremely easy to see comparisons across groups. And so here what we can see is that for EU countries, you have the first wave, you have the second wave, which is very clearly there. So the continent was really in the middle of it, and it was half the deaths of globally around this time. Here, what we can see are the vaccination effects. Some countries are high, some countries are not. So again, for some types of data where you see some movement over time that can be linked in XY space, helps, like these visualizations work with all of that. And so because the joy plots can deal with basically it's a three-dimensional plot. So you have XY coordinates and you have a height. And that makes them also very applicable for other applications like visualizing map data, where you have XY coordinates and heights or elevations or populations. So again, this is something that I came up with for this presentation, was to combine these two layers actually. So this is data extracted from raster. So Italy I just took because I think it has an interesting landscape. People don't realize how hilly it is, but again, this is a joy plot representation in Stata of elevation and population data that can be easily extracted from rasters. So here we can see major cities. So here is Rome, for example. Here is Milan, and then you can see how the split is between how the cities are spread across the mountains. And so again, one can come up with interesting types of visualizations, but the point is that we have the tools that allow us to do this sort of stuff. But rather than pushing ourselves to do these fancy visualizations, which are sort of like one-off projects, Stata has this already an amazing package, which is this SPMap package, which allows us to do quite a bit of stuff. So as David mentioned, so I do these very basic training courses on how to use this package and combine it with color schemes and stuff like that. So this is just a basic package where we have plotted median age in years by NUTS 3 regions, which are the smallest administrative units on which data is collected. So what we can see here is that, of course, these regions are varying in size. You have some very massive regions. You have some extremely small regions, and these regions are determined by population size. There's also some projection level distortion happening where Finland and Norway are being stretched a bit. But, when you look at this map and you say, okay, what we see is an overall distribution of median age. And, we can see the patterns that we know for sure that, Central European countries are older than the periphery countries, for example. And, this is something I don't want to go into demography, but this is a constant point of discussion in these kind of topics. So from a visualization point of view, the main challenge here is that we can give an overview, but we really cannot see the specifics of certain countries in detail. For example, if you look at Germany, Germany has extremely small NUTS regions. And then if you say, okay, I want to zoom in, yeah. But if you look at Germany, you can see this huge discontinuity around the border. Yeah. So if you look at Poland here or Czech Republic here, you can see this huge discontinuity. So the idea is that, okay, we can use an if condition and zoom into Germany. That's extremely easy. Stata allows us to do that. You can make the map, you can zoom in. But what we want to do is sort of compare it with regions around it. We can add regions. We can say, okay, you can do SPMap, whatever, median age using this if country is equal to Germany or Netherlands or Denmark. Yeah, so we can do this and we can see these comparisons. But it becomes cumbersome if you want to sort of create a box around this. We can then also say, okay, let's do a box. We can say, let's define the bounds around this country and let's see what we come up with. So if we define a box, yeah, you can say if X coordinate is between this and this, and if Y coordinate is between this and this, give me a map. So you can get this map, which looks something like this. So you can see parts of UK are there, you can see Poland is there, other countries are there. But let's say if you use the same bounds to come up with, also you want to clip the country level boundaries, and then you plot this, it starts messing up the data structures. Yeah. So the idea here was, can we systematically cut or clip boundaries so that we get a neat zoom in effect of a region rather than come up with this extremely messy figure where you're sort of patching things together by doing a lot of if-else conditions or manipulating shape files. And so this was also a super intense coding exercise where we say, okay, let's look at algorithms that other softwares are using to clip geographies. And so this is one algorithm, which is the Sutherland-Hodgman Polygon Clipping algorithm. And so without going too much into the logic, what we have is that we have polygon files that needs to be sorted in a clockwise or counterclockwise order, which they are by definition, because that's how the shapes are created. And you need a bounding convex shape. And so it needs to be convex, which means it can be any shape. And all the requirement is that it needs to be clockwise and fully closed. So this is the fastest algorithm. It's the most, not the most efficient algorithm. But again, once we program this, then all we need to do in the Stata script is identify all the independent shapes that exist, identify the points which are inside or outside this shape, so which can be done with this geoinpoly command by Picard. And then we take the partially inside points, shapes inside the box, and then clip it using the this algorithm. And because we are talking about shapes which have points and which have a specific order, so behind the scenes, there's a lot of reshaping happening. And then what we can do is run this algorithm and generate a new file which has the clipped boundary. So again, nobody has seen this before. This is the first preview of this figure where we have clipping along a box happening. So what we can see is that we define a box, and what we can see is that all the islands and all the boundaries are fully clipped without error. There is one error. I still need to figure out why this is happening. And so the idea here was to, start working on different aspects of shapefiles where we allowed algorithms to fully allow us to zoom in or zoom out. And so so again, this is a combination where I'm also from a programming point of view, it's a combination of Mata scripts, frames. And so again, steep learning experience for me as well. And like I said, these are not the only types of clippings that one can do with this type of algorithm. One can do other types of clipping also. For example, this is a hexagonal clipping. So, as long as the shape is convex, one can do these kind of different elements. And, given this package has this flexibility to take in any types of shapes and stuff, one can do quite a bit with this kind of things, especially if you want to zoom into regions or other things. Again, a lot needs to be worked out. The main thing in this was to figure out was basically when you run the SP shape to data command, it generates countries. So basically all the islands have to be separated out. So again, there are some additional steps in doing this. But again, relatively one of the easier things was to implement. Of course, there's always a lot of bug fixing with this stuff, but sort of a low-cost program with a very powerful application for data visualization. And so this is polygon clipping, yeah, and polygons are not the only type of shape files we have. We also have lines, and so this is the street grid of city of Vienna. So I'm just using these maps because I work with this data all the time. And so I have this always at hand, or I know where the files are, for example. So this is the Vienna street grid. And again, we can run the Sutherland-Hodgman algorithm on this, but there are other algorithms that also deal with line clipping. And line clipping is sort of very different from polygon clipping, where you have to preserve the boundaries of the shapes. Line clippings are relatively easier because all you're saying, okay, just throw this line out. Yeah, so these lines are just a bunch of connected points. So if you throw out 2 out of 5 points, then you're just left with the shape. And this also easier to do in Stata. You just say, okay, SPMap, whatever, using this. If in box, you can define a box boundary. If you do that, you will get something like this, basically, where you have, these sort of hairs sticking out from the edges. And this is also fine in a lot of circumstances. And because these are streets and they are extremely fine in how they're defined, it works here, but it might not work here for other types of line files where you have, I don't know, highways cutting across. So here, for example, you can see this road sort of continues, but because it was one large road link, it got dropped up from this image. So for this visualization, for this grid map, it sort of works to use a box condition and just say, just draw a map using these different bounds. And so, but there are line clipping algorithms as well. So one of the popular ones is this Cohens algorithm. And so what it needs is basically lines. There are 2 endpoints. So you have x1, y1, x2, y2. You need a bounding box. And again, the script sort of functions like this, that you first identify lines which are fully inside or outside, and then the lines that are partially inside, you just clip them based on the intersection. So again, a lot of stuff has to be preserved in where the order is, because you can have lines that are completely cutting across the box, which then are clipped in the sense that you are still preserving stuff which is inside and stuff which is outside the box. And so there is a beta version of this on GitHub. So I'll share the presentation so you can also check out this algorithm or test it out with data. So using this script, one can also then basically clip the road files. And here you can see that this is now fully clipped, so nothing is sticking out. So if I could quickly compare this, you can see these small hairs sticking out, and these are now gone. So what you have is a box which is fully contained in terms of this. And so, yeah, once you have generated this shapefile, you can now save it as a shapefile, as a clipped shapefile, and then you can also then call it with SPMap. So here it's used with SPMap, where you have the clipped edges. Again, you can say, okay, I just want to zoom in. So again, without defining a lot of conditions, you can just say, okay, I zoom in more. So it sort of keeps it neat the more you zoom in. And so let's say the other algorithm for polygon sort of supersedes this polygon. So if you have polygons plus lines, you can use that to clip all the geographies. But if you're using just lines, you can use this. It's extremely fast. So I've tested it with over 1 million observations. And now with the combination of frames and other things like using views in Mata, for example, one can do this extremely fast, basically, these kind of clipping algorithms. Again, they have some data restrictions that stuff needs to be sorted and ordered. Yeah, but again, the more advanced algorithms also need a lot of more time investment. So I do plan to work on them, but let's see. So moving on. So these are the clipping algorithms. So what I want to briefly discuss now is, again, going in the spatial stuff, is that we can take this sort of data structures that exist. So these are all this stuff that had to be programmed in. Yeah. And so one does not have to go so far as to, program everything in. One can also use existing structures. So for example, this is a population density map. Yeah, all it has is our XY coordinates, and this is a dot scatter plot, which has weighting based on populations. And so, yeah, one can even go do simple stuff and still come up with interesting visualization, you know, like it needs no packages, for example. This is sort of maps that are created using SPMap. So what we're doing here is combining SPMap with the color palettes package that allows us to combine different elements to come up with maps which are easier to read. For example, here we're looking at median age and dependency ratio. Dependency ratio is share of people over the age of 65 and under 15 as a share of working age population. So the idea here is to show that, for example, in East Germany, not only is the median age very high, the dependency ratio is also very high. Similarly, in Italy, parts of Italy. So for example, yeah, so this is just to do with the burden on the population in these regions. Yeah, other things one can do is this basically takes the Facebook connectivity data. So it's looking at how much social connectivity each region has with other regions. So not looking at within country connections, which are obviously extremely high. But for example, for the UK, we can see what's the share of what are the highest 10 regions where we have the highest number of Facebook users talking to each other. And so this data is extremely powerful. So we can see how much parts of the UK are connected to the East European regions. These are the top 10 regions. Of course, it's a complete matrix, so you can plot everything on this grid. But here the idea was to sort of combine the SPMap with other elements. So this is maps plus spikes. So it again allows for very interesting visualizations if you have this bilateral flows sort of data. And so this stuff I'm still exploring a bit more in how to make it visually more interesting. So you might see something more on this in the coming months. Again, an extremely popular map was this bivariate map, which is extremely easy to create. What you need is color ordering, basically on 2 dimensions, and then their combinations. So there are a lot of palettes that exist. And so this is again a map. This is also again a map on which a lot of people have sent me a lot of stuff that they've done. And again, very interesting work can be done with this kind of stuff. Not always useful in all circumstances, but you know, for this application. So I think I saw this map a long time ago somewhere, and I said, okay, I'll try and recreate this in Stata. So this is by race shares by counties in the US. I've seen people have sent me a lot of other interesting stuff also. For example, emissions levels and race categories, for example. And so if you have these sort of bivariate distributions, you can use these type of maps. These are fairly easy to come up with. What's also very easy to do is start combining Stata with Openstreetmap data. So one can download these layers. So I've reduced the resolution of this image because the presentation was getting huge in size, but it's extremely detailed. You can combine actual spatial data, and here what you can see is that the clipping is taking place, but this clipping was done in QGIS before exporting. So the idea was that, again, eventually end up at a point where we are pulling data directly from the OpenStreetMaps API and clipping everything. So the aim is to eventually go fully native routines without relying on third-party softwares. This is another representation, also extremely easy to make, because what we're dealing with is just a representation of space, not the actual space. So these are tile maps. So again, these are COVID-19 cases by states for the last 2 months or so, or 3 months, where we are looking at how cases and deaths are evolving. So this is one variation. This is another variation. So essentially, once you have the tile grid in place, you can throw in any graph and just let Stata do the layouting for you. Basically, what you need are just where these tiles need to be placed. So you can replace it with a pie chart or a bar chart or anything in these boxes. And so yeah, what's still in the pipeline that I'm still working on. So which is, again, this is my project that I've been working on for like a half year last year. So again, there's a package online, which are Delaunay triangles and tessellations and convex hulls. So this was quite intensive coding. The package is up, you can test it, it's on GitHub. In terms of its application, I'm still working on fine-tuning the code and coming up with different things that one can do with this. So again, I didn't want, I can do a whole presentation on just these two figures. Yeah. So the idea was to just tell you that this is out there and it's being worked on, and there are a lot of applications of triangulations and tessellations in maps, especially if you want to look at nearest distances or nearest schools or nearest shopping malls or stuff like that. So a lot of stuff can be done with this. Triangulation is extremely helpful if you want to do sampling of points within certain shapes. So triangles, as you know, is the most convex shape possible, and it is the easiest one to handle by computers. So more on this again later this year. Other thing that I'm working on are Bezier curves and splines. So this is just one application of Bezier curves. So what I want to do is sort of go more into the area of replacing straight lines with curves. And so with curves, you need to have a good control over control points and how the curves are drawn. Again, a whole presentation can be done on just these lines and curves, but I just want to tell you that a lot of options are possible with what we have already within the native Stata code structure. And so just to wind up quickly, this is sort of, I'll share this presentation with you guys. So there's a lot being done. A lot was written up in the last year. So I wrote over 48 different guides on Stata. I was doing this map challenge. I have a small gallery where all this data is in one place. So I was lucky enough to have the Stata map stuff featured on the World Bank's Development Impact blog. So, you know, there is demand for this. People are reading this, people are interested in this. And so I try to post not as frequently, but as evenly as possible. So, you know, the interest is there and people reach out, which I really like, sometimes with very tough questions, which, you know, helps improve some of these packages also. And so I just want to finish the last slide with, you know, stuff that would be nice to have in Stata and would be nice to have, you know, to help improve the visualization. So again, this is a huge wish list, but just to put it out there, this would be nice to have this in this data. So this is it for my presentation. So I don't know if I was too fast or too slow, but yeah, so I wanted to leave some space for questions.
Asjad, definitely not too fast and definitely not too slow. You've covered an awful lot of material there, and we've seen some pretty amazing graphics, and to think that they're all done in Stata, that's impressive. So we have got a couple of questions that have been coming in on the chat.
Should I stop sharing my screen? Is that
if you want to share your how about I'll take a screenshot of that one and I'll make sure Jeff sees this one. And then because that's important feedback for Stata Corp. There is one thing you've got on there about ability to add images in, or colored images in the background. I've got, and
also the ability to read images.
You can do that. We used to have it up on our Tech Tips site, but it is so difficult to do that we took it down. But I've still got the text on how to do it. Yeah. So have we, the questions that we've got on here. So we've got a question from Van Hui Nguyen. Where can you get the Stata codes or materials?
Yeah, most of it is here on the Stata guide. Actually, quite a lot of it is there already. Stuff that I've shown that's not there is all new. Most of it was done last week, so it will be put out there soon.
And I know from experience, by following you on Twitter, I'm able to find a lot of the links in your new graphs when you're putting them out there. And I really enjoyed when you were doing your 30-day graph challenge, or your 30-day map challenge, because it was a new map every day.
So the thing with fancy visualizations is that if I put something out and people like it, there's a certain burst of, okay, share the code with me. But at the end of the day, extremely few people start actually diving into it. So the code is all online, just because I want to avoid responding to a lot of emails. But if you use it, if you have feedback, please let me know. So I'm reworking some of the guides based on feedback. So for example, the Sinkey guide will be reworked completely based on user feedback. And so if you use them, please send me stuff on how to improve this. Yeah.
Yeah. Have we got any other questions here for Asjad? Questions from the group. So Asjad, can you remind me when is your course? Is that the 28th of February?
I think it's the 25th. So it's just a basic introduction to, it's a bit more of like dealing with maps. One comment I see in the is torturing Stata II low. Yeah, I mean, that's how the other softwares also did it. So, and so a lot of it, so the way I do it is I have a huge script. So let's say the interesting part for me is the process. So the way I write the guide is I describe the process of how it can be done. But what I want to do now, from now on, is not do so much the process, but you know, there are small programs one can write that can be called in by a lot of different visualization types to put this together. And again, this is how it's done in R also. You keep calling packages within packages. And so let's say one example is in the Sinkey's that has more universal application is, is how these curves are generated between 2 points. So basically this is a logistic function that's stretched to fit in an area field. So for example, for this, rather than explaining how one can do this, I can just say, oh, just download this package which does this for you, where you say, give me an endpoint, starting point, endpoint, and the type of curvature you want, and it will do that for you. So this kind of packages need to be developed for Stata. And again, like, you know, I'm already using SPMap with color packets, which are 2 different packages. And so one should start combining these different packages that can do these different types of visualizations.
Just a quick question from me.
Yeah.
What when you create these graphs, you save them as a .gph?
No, I save them as I just export them as PNG.
But you had, when you first create them, if you wanted to save them, you could save them as a Stata.gph file.
Yeah, so this is GPH file because this is graph combined. So here I have to save them in native Stata code. So for each state, they are saved and then combined using graph combine. So
very cool. Now we've got a question here from John. John, do you want to go ahead and ask your question?
Yeah, amazing presentation as always. I was just thinking like taking it maybe also to a next step in the sense of having more dynamic visualizations, in the sense of these are graphs that you've created, but maybe there's some way to write dynamically the code such that given my parameters, these types of graphs can be generated or changed or moved or zoomed, etc. There is no real concept in Stata of an engine, visualization engine, but maybe through you know, like clever dynamic programming, you can, you know, have a control mechanism that depending on its parameters would create this on the fly or change it or move it or you know, like change the contents of the graphs.
So John, a interesting webinar for you to catch up on is the webinar that Laura and I ran on graphs last year, and how you can actually extract all of the configuration and changes that you do on a graph through the .gph file. So all of the changes that you do to a graph. So if you want to specify the color, yep, or the location of data points, all the different configurations, you can actually get that in the .gph file if you just open it up in a text editor.
Yeah. Excellent.
Yeah, on the dynamic stuff part, one thing is putting the graphs through some algorithm which say, oh, for this type of variable, this type of graph would work. So that's one whole thing. The other thing is the dynamic part. So I think Austin just briefly showed that one can do this in JavaScript. So I think a lot of this dynamic stuff can be programmed in because data allows integration with Java and C. And so programs can be written which allow for dynamic visualizations. So by dynamic, I mean you have levers and pointers and 3D graphs you can move around or rotate.
Exactly.
Yeah, and the other thing is that which graph works for the data set. I think that's a whole research question. It's the same as finding the parameter space, for example, using lasso regressions. And so I think a lot of people are doing stuff in that end also. So I think it's definitely worth looking into. Yeah. But it needs some serious programmers doing this serious coding for this kind of stuff. Yeah.
Asjad, I'm going to ask you one more question. I met with an economist a couple of years ago, and he was trying to calculate the market price of houses in Australia based on the distance from the local train station. Mm-hmm. And he was really struggling because the data he had was point-to-point data. Now, I notice you've done in your maps, can you actually calculate the street distance as well? Because if you've got a house on a street where you have to drive over a bridge to get to the train station, that may affect the price of the house, where if it was the calculation was done on as the crow flies, it would be a much shorter distance. So can your visualization and use of SPMap help with that?
So there are two things. One is direct as the crow flies distance. So there is the GeoNear package by Picard, Robert Picard, which can do that in terms of factoring in the landscape. What one can do is one can ping the Google API and say, get me the walking distance or biking distance or between 2 points. So one can do that as well. But I think here one needs to write some script which allows us to do that. And there are also limits to accessing the API, just the same with Twitter API. So that's one option. The third option is if you have the street layout, then basically what you're doing is you're doing network pathing on in Stata, where you're calculating the shortest distance on a path. So here one needs things like the A* algorithm implementation in Stata. So all three things can be done. It's just a matter of someone needs to invest time in programming this. So I did not touch networks at all in this presentation, but the whole network stuff, one can do a lot of exciting things. And yeah, so that's something that's also worth investing in terms of visualizations and setting up this native code. So in short, the answer is yes, it can be done. It just needs to be programmed in.
Okay. Well, Asjad, thank you very much for your presentation this afternoon, or this morning, I should say.
Yeah.
It's been...
yeah, thank you, David, and the organizers for giving me this slot. So I really enjoy doing this, and thank you again for the opportunity. Yeah.